In this presentation, you're going to learn everything about quadratics. The problem that we're using is that Lindsay is playing fetch with her dog. She throws his toy and it takes the path of the function h of t equals negative t squared plus 4t plus 5, where h represents the height in inches as the toy travels in time t seconds. This is the graph of our real-life parabola. The y-intercept of this graph is 0, 5. This represents that when the ball was thrown, it was initially 5 inches off the ground. Next, we're going to look at the vertex of the graph. The vertex is 2, 9. However, if you don't have a graph, you can also solve algebraically. Because you can find the vertex, or hk, of a function, you can substitute negative b over 2a from your original function to find h, and then plug that back into your function to find k. Algebraically, the function would have the vertex of 2, 9. What this means in real life is that the highest point my ball reaches will only be 9 inches off the ground, and that will come 2 seconds after it's been thrown. The axis of symmetry occurs at the vertex of the graph, or where there's a change in direction. In relation to this problem, 2 seconds after the ball is thrown, it then begins to fall. Next, we're going to look at the solutions to the equation, or the x-intercepts. On this graph, you can see that it's crossing the x-axis at negative 1 and positive 5. However, again, if we don't have a graph, we can also solve this algebraically by factoring in the quadratic formula. By factoring algebraically, you can also determine that the two solutions would be 5, 0 and negative 1, 0. Solving using the quadratic formula also yields the same x-intercepts, or solutions, of 5 and negative 1. In relation to our real-life solution of throwing the dog toy, negative 1 and positive 5 would represent when the ball hit the ground. Because time cannot be negative, negative 1 cannot be a possible real solution. However, 5, representing after 5 seconds the ball returned to the ground, is our only real solution. This concludes the presentation on the real-life interpretation of quadratics.